We would like to thank you for the information that you brought for us.
Okay.
This is like a dream for me. Everything predicted in their blood seems to be written in their faces. It's like looking at a composite model of every face from around the world. The eye shape of East Asians, the high cheekbones of Mongolians, the mid-brown skin that could turn darker or lighter. So how do I know that of all the people on Earth, the San are direct descendants of our oldest ancestors? I'll try to explain a little better this time. I work with DNA, our very own manual of life. It's in our blood, in every cell of our body, orchestrating our life processes. DNA is a ladder of just 4 linked molecules, A, C, G, and T, strung together in pairs in an incredibly long and complex sequence. If laid out, the DNA from one person would stretch to the moon and back 3,000 times. In our cells, this chain is broken into 46 bundles called chromosomes. Because of its sheer length, DNA is prone to develop small glitches in its sequence. They're called mutations. Everybody has them. When they occur, we pass them on to our children. We call these inherited mutations markers. As our chromosomes pass down through the generations, they carry these markers with them. They write our history. They are the source of our time machine, the way we can see back to our earliest ancestors. The markers I follow are found only in men, on their Y chromosome, the chromosome that makes men men. But of course, men don't travel alone, and the journey of man is the journey of everyone.
I was walking through the village and I saw that they had massive piles of these sitting around everywhere. We call them monkey oranges. And they taste pretty good. They're a little bit like papayas. But I thought it would be a good idea to use them to explain exactly what we mean when we say we're following genetic markers. This is a man at some point in the past. The thing that makes him a man is his Y chromosome, a piece of DNA that's unique to men. When men have sons, they pass on their Y chromosome to those sons. Again, it's what makes them sons. So if we imagine that this man had 2 sons, they would have essentially identical DNA on the Y chromosome to their father. So they would get his Y chromosome in effect. And if we imagine that they also have sons, those sons, the grandsons of this very first man, would also have essentially the same DNA. But occasionally, when we pass on these pieces of DNA, we get a change in a single letter in the sequence. We can call those mutations or markers, and that's what allows geneticists to trace descent. Now I've represented this marker with a little strip of tape, a little black bar. And just like before, all of the sons of this particular man will have essentially the same Y chromosome, so they will inherit this marker. And in that way, the marker acts effectively as a badge of descent, a marker of descent from this particular man, and that's what we follow. Now, as we move further down the tree, most of the sons will inherit just that single bar, but occasionally, as we saw before, we will get a second change in the Y chromosome. A second marker appears, showing descent from a particular man, in this case this person, who has first that marker, which came from that person back there, but an additional unique change on his Y chromosome, which he then passes on to all of his descendants. So in the people that we're talking about living in the present day, in this part of the tree, they've got 2 markers. They clearly trace their descent from this man, but the first marker, remember, arose all the way back there, all those generations ago.
The San Bushman markers are quite unlike any others found outside of Africa. In the world's family tree, their branch is the first to split from the rest. That's how I know they must be the oldest tribe on Earth. And now I'm here with them, looking for clues to find out why their ancient brothers and sisters left this place.